Standing here with Greg at the NVIDIA booth at SIGGRAPH. Hi, Greg.
Hi.
How is the show going so far?
Amazing. It's a really good show. Every year for us, SIGGRAPH is kind of our thing, and we're really glad to be here.
Yeah, I'm wearing your name right here. It's great.
Thank you very much.
And you have quite the booth. It seems like you have a lot going on, a lot to share. What are some of the main features that you're putting out this year? I know you have something going on with VR.
Yeah, VR is definitely one of the big themes for us. There's a couple things in VR that big problems to be solved. People have been able to use it for gaming and really enjoy it for gaming for a while now, and that's obviously getting better and better. But one of the things that we're showing is to use it for professional use. And to do that, if you were trying to look at a full model of like a car or a nuclear submarine or whatever it is that you want to look at, until now there hasn't been a way to actually view the real model. They'd have to dumb it down so that it would work in VR, but when you do that, it's hard to make design decisions and change it. So with our partner Dassault Systems and their CATIA system is one great example. We're showing how right within the application you can view it and make changes in VR. So that's one example. A second one that we're doing is we actually have a VR simulator called Holodeck. And that's a collaborative area where we can have multiple people in. We've got the Koenigsegg car in there in all of its glory, and you can collaborate from different rooms or different places, and everyone can see each other in VR and actually, change the color on something or decide the steering wheel needs to be moved a little bit, or a lot of amazing things. And so it's becoming a lot more practical for real design work in a way that it wasn't before. Then the third thing in VR that we're doing, which is really cool, is we have a robot here, and we have a robot simulator. And we brought this robot simulator, Isaac we call it, into virtual reality. So you can actually go into VR, interact with the robot, have the robot learn an artificial intelligence in VR, take that neural network from VR and put it in the real robot, and the robot knows how to do things it's never been trained to do in real life in the physical world. So it's pretty darn cool.
That is phenomenal. That's fantastic.
Yeah, and that's another one of our big themes here too, is really artificial intelligence in general, AI, right? In a couple words, we're bringing AI to graphics. We've been in this business for 25 years, and we started doing everything in graphics, and over time we took that in to use our graphics processors for compute, and then we took that into AI, and now we're kind of bringing it full circle to bring AI to graphics. So here you'll see a lot of examples of that. One of my favorite is style transfer. So for instance, you could have live video come in, you could tell the neural network to have it look like Picasso or Van Gogh and turn it into that. But we're doing so many other things. We're bringing AI to the process of ray tracing and rendering. So we're doing denoising here. It's 157 times faster than a CPU node in a rack. And so just that kind of advance makes it so that if you're a CG designer, somebody who's working in VFX, you can now do ray tracing in real time, basically, and it is gorgeous without all of the noise and the speckles that you might used to see in a ray tracing environment.
Well, it certainly seems like you're making many people's process far more efficient across the board.
It is.
An artist, a car designer, whatever the case may be. But it also seems like with VR, AI, this will take very high-powered workstations, quite the setup in order to make it run. Does it? I mean, how do you compensate for that?
Well, the thing is, if you think about, if you take like all of the visual effects artists and corporate marketing departments and the people doing CAD, there's probably 25 million designers out there today. And they're having to deal with designs that are getting larger and larger. The resolutions, like we're doing 8K video editing right behind us here. The resolutions are getting larger. You add VR on top of that, you add AI on top of that, and it's more. But the systems that we all want to use, the laptops, they tend to get thinner and lighter. They're less. So you see this big gap happening. So one of the big announcements that we have is what we call eGPU, an external GPU. So it's a really easy concept. You can basically take our highest end Quadro or Titan, put it in an external system, connect it through Thunderbolt 3 to the thinnest and lightest laptop that you can imagine, and you can get the full power of the highest end NVIDIA machine right on your PC notebook over Thunderbolt 3. And then now you can do all those things. You can do VR, you can do simulation, you can work in higher resolution. So it's pretty cool, because then you're still mobile when you want to go on an airplane or do whatever, and you're not tied to that, but then you go to work, plug in one cable, and bam, you got it.
That's phenomenal. Thank you so much, Greg.
Thanks for having us.
Absolutely.
Really appreciate it.
No problem.